Welcome to this video lesson, which is the full solution to the practice questions from lesson 15, which covers the angle between two lines. The first question today asks us to determine if the following lines are parallel, perpendicular, coincident, or neither. We can start off this one off with just finding the angle between the two, or we can kind of test to see whether they're parallel, perpendicular. And if they are parallel, then we can test to see if they're coincident as well. And if they're neither parallel or perpendicular, they're going to be neither. So let's do it by checking. So we're going to check whether or not the two lines are parallel. To do that, we're going to test to see if the direction vector b1 and direction vector b2 are a scalar multiplication of each other. So in this case, is b1 equal to some value k times b2? We do that simply by writing all the x, y, and z components of the vectors, so 6 to 0, and check to see if that will equal to k multiplied by -9, -3, and 0. You could have done b2 is equal to kb1 or b1 is equal to kb1. It doesn't really make a difference at the end. Now we're going to take all the x, y, and z components, and we are going to test to see what the k value is for each one. So for the first one, we have 6 is equal to -9k. For the next one, we have 2 is equal to -3 times k. And for the last one, we have 0 is equal to 0 times k. Let's find the k values here. For the first one, the k value is 6 over -9, which simplifies to, actually I'll just write it as 6 over -9, which simplifies to 2 over -3, or just -2 over 3. For the next one, k is equal to -2 over 3. And for the last one, k can also equal to -2 over 3, because if we plug in k is equal to -2 over 3 here, we will get 0. So in this case, these are all consistent, meaning that the lines are parallel. Now, by knowing that the lines are parallel, we know that we cross out these two options and we're only left with either them being just parallel or them being parallel and coincident, meaning that they lie on top of each other. So we can either choose R1 or R2, write the equation, and test to see if one of the points here lies on this line, or if this point lies on this one, or any other points. Really, we can use any lambda value. So let's do R1's equation. So R1's parametric equation. I like using parametric equation for this. It's a little bit easier. X is equal to 1 plus 6t, y is equal to, actually I'm going to show you what we're doing here. We're just doing all the x and y and z components. That's -1 plus 2t, and z is going to equal to 1 plus 0t, or just 1. Now here's the equation, and in this equation, the x, y, and z values represent any point on this line. And we're going to test to see if one of the points on R2 lies on this line as well. And to do that, we can choose any point here. If we choose a lambda value of 0, then this crosses out and we're left with this point, -5, -3, 1. Now, I just want to emphasize that you can choose a lambda value of anything. You can choose 1 and then use another point, maybe -5 plus 1 times -9, -3 plus 1 times -3, and 1 plus 1 times 0, and choose that point. But the easiest one is that initial point over there. So in this case, the points on R2, we know that point -5, -3, and 1 lies on R2. So we're going to test that. We're going to see if those values actually are on R1 as well. So X, Y, and Z values. For X, the X value is -5, and we want to see the T value for which that's equal to 1 plus 6T. For Y, the value is -3, and we want to see for what T value that is equal to -1 plus 2T. And for Z, the Z value is just 1, which is equal to 1. So Z makes sense already. Let's test for the other two. For these two, for the first one, 6T will equal to -6, so T will equal to -1. And for the other one, I'm going to add 1 to both sides, so I will get -2 is equal to 2T, and that means that T is equal to -1. Since T is consistent here, and since this is also consistent, 1 is equal to 1, therefore that means the points -5, -3, 1 also lies on line which is defined by vector R1. Therefore, they are both parallel and they share a point, and therefore they are coincident lines. For the last question for the day, it's in two parts, and for the first part we want to determine the angle between the following lines. We got two lines. The first one is given to us in Cartesian form, and the second one is given to us in vector form. In order to find the angle, we need the direction vector for both lines. So we need B1 and we need B2. B2 is easy. B2 is just the direction vector is just here. So I'm going to use 3, 8, and -5. And for B1, we got the proper format here. It's x minus 2 over 3. So 3 is going to be the x component. For y, we have 3 minus y, so this can be changed. So we get 3 minus y over 16. It needs to be y minus 3. So this is the same as -y minus 3 over 16. Note that when we do this, a negative times y is negative y, and negative times -3 is -3. Another way of thinking about it is factoring out a negative, and 3 divided by -1 is -3, and negative y divided by y -1 is positive y. Then we will shift the negative on the denominator, and we will get our components. The y component of our direction vector is as -16. Finally, for the last one is z. This is like z minus 0 divided by 7, and therefore 7 would be the z component of our direction vector. Once we have all of this, then we need to use our equation. Our equation says that cosine of theta is equal to the magnitude of b1 dot b2, the dot product of the two direction vectors, over the magnitude value for each. So let's find the dot product first. So the dot product of b1 and b2 will equal to, we got b1, which is 3, -16, and 7, dotted with 3, 8, and -5. And what we'll have to do is we'll have to take their x components, multiply them, y components, and the z components, and then sum them all up. So here we will have 3 times 3 plus -16 times 8 plus 7 times -5, and we will get 9 minus 128 minus 35, which will give us -154. We also need the magnitude of B1 and magnitude of B2. The magnitude of B1 will be the x component squared, which is 3 squared, plus the y component squared, plus the z component squared. And this will end up being square root of 314. We're going to do the same thing with the magnitude of B2, and it's going to be its x component squared plus the y component squared plus the z component squared. And this will end up being root 98. Now we can plug all the information into our equation. So let me highlight some values here. This is going to go here, this is going to go here, and this is going to go here. Now we're going to plug everything in, so we're going to have that cosine of theta is the absolute value of negative 154 divided by root of 314 and root of 98. This is going to equal to, we got the absolute value or the modulus of negative 154. That means we got to take the positive value there. I'm going to divide that by 314, root 314 and 98. And again, you can multiply these out or write it like this. It doesn't really make a difference because we need to put this in our calculator. And we're going to use the inverse cosine function to get our final answer as approximately 28.6 degrees, and that's the three significant figures. And there we have it. This is the answer to the first part of the question. For the second part of the question, we're told that line 3 is perpendicular to line 1 and has direction vector of 0, y, and 48 in the x, y, and z directions, and we want to determine the value of y. So to figure this out, we know that when two lines are perpendicular, their dot product is going to be equal to 0 for their direction vector. So we've already found a direction vector of line 1 in part 1 of the question. So line 1 has B1 is equal to 3, negative 16, and 7, and line 2 has line 3, excuse me, has B3 is equal to 0, y, and 48 as the x, y, and z components. For lines to be perpendicular, that means that B1 dot B3 is going to equal to 0. So we can write those components down. We got 3, negative 16, and 7 dotted with 0, y, 48. It's going to equal to 0. We are going to take the x, y, and z components, multiply them by each other, and sum them all up. So we will have 3 times 0 minus or plus negative 16 times y plus 7 times 48 is equal to 0. 3 times 0 cancels out to 0. We are going to have negative 16y plus 336 is equal to 0. I'm going to subtract 336 from both sides to get negative 16y is equal to negative 336. So here we subtracted 336. And now we're going to divide both sides by negative 16 to get our y value as 21. And the y value has to be 21 in order for the two lines to be perpendicular. I hope that this video gave you some practice on how to find angle between two lines and what kind of skills you can actually use to figure out when lines are parallel, perpendicular, or coincident. Thank you for watching.